Okay, hello everyone. Let's get started on the next page. Okay, proving basic trig identities. So this is more trig identities. The expression cotangent secant theta secant theta is equivalent to what? So cotangent is just cosine over sine. So we'll do cosine over sine theta here, and then secant is 1 over cosine theta. When you multiply these two together, the cosines cancel out, leaving 1 over sine theta, which is secant, or sorry, cosecant theta. And so that first one is B. The expression here is equivalent to, so secant is just 1 over sine, so that'll be sine of theta on the bottom. Cosecant is 1 over, did that backwards. Secant is 1 over cosine, so I would move this down. I can change it to cosine, so that'll be cosine on bottom. Cosecant is 1 over sine, so that's the reciprocal. As it moves to the top, it switches to be sine theta, which is just tangent of theta. So, nope, not that one, not that one. Sine over cosine, so that one would work right there. This next one, number 3. The expression 1 minus cosine squared theta over sine squared theta is equivalent to, well, 1 minus cosine squared theta. That is a Pythagorean identity. That is the same as sine squared theta over sine squared, or sorry, x theta, whichever, which is just positive 1. Okay, so here now we have 1 plus cosine x times 1 minus cosine x. So what is this equal to? So there's no squared. Notice that this isn't. Let's see if I can't get that glare to fix. Okay. Notice that these cosines aren't squared at all. So this is not a Pythagorean identity. However, this is difference of squares. A plus b times a minus b is equal to a squared minus b squared. So a is 1, b is cosine. So if I multiply or FOIL these out, whichever one you want to do, you get 1 squared minus cosine squared x, and 1 minus cosine squared x is just sine squared x. So that's going to be B right there. Okay, the expression cosine squared for theta plus sine squared for theta is equal to, well, cosine squared of an angle plus sine squared of an angle. It doesn't matter what the angle is. It's 1. Pythagorean identity. The expression sine of a plus cotangent squared a times sine a is equivalent to, okay, well, let's see here. Let's factor out. So it's hard to kind of see where these are. Okay, so here I have sine a, so this is 2 terms that have a common factor. I'm going to factor out sine a. So this will be sine a. Factor it out of that one, that's going to be 1. Factor out of this, it's going to be plus, so that would go away. Cotangent squared a. Now 1 plus cotangent squared a is a Pythagorean identity. That is equal to cosecant squared. So this will be sine a times cosecant squared of a. And then cosecant squared is just 1 over sine squared of a times sine a. So I have a sine on top that cancels out. One of the signs on bottom. I'm left with 1 over sine a, which is cosecant of a. So that's going to be D. Number 7. If theta is a positive acute angle. So a positive angle less than 90. So we'll have a, before I even read the rest of it, if I see that, I sort of draw it. So this will be theta. Okay. And sine of theta equals a. So this means that here, this would be a, and that's 1 if sine of theta equals a. Which expression represents cosine in terms of a? Well, cosine is adjacent over hypotenuse. So I need to figure out what this adjacent side is. And I know that a squared plus the adjacent side squared equals 1. So that tells me that, well, so cosine squared of theta, we use the Pythagorean identity, cosine squared of theta is equal to 1 minus sine squared of theta. But I know sine squared of theta is a, so I'll just plug that in here. This is equal to 1 minus a squared. And then, so I would take the square root of both sides, so I would get the square root of 1 minus a squared. The square root of 1 minus a squared. Simplify each of the following. So sine squared of beta times cotangent of beta. So the first thing I do is I'm going to make all of these in terms of sine and cosine. So I got sine squared of beta times cotangent is cosine of beta over sine of beta. And all of that is over cosine of beta. So I have a sine on bottom, on the top, in the numerator. I have a sine on bottom and a sine on top. So those will cancel out. That will give me sine beta times cosine beta all over cosine beta. Well, cosine beta cancels out with cosine beta, leaving just sine of beta. Okay, sine x minus sine x of cosine squared x. Okay, so here I have some addition and subtraction, but there's not an easy way to see a Pythagorean identity here. So these have a common factor. Let's factor it out of sine x. That'll be 1 minus cosine squared x. So sine times 1 minus cosine squared x. 1 minus cosine squared x is just sine squared x. Sine x times sine squared x is sine cubed x. And the last one here. So sine squared of x plus cosine of pi over 2 minus x minus 1 plus cosine squared x. Okay, so, well, let's see what we got here. I have a positive sine squared x here and a positive cosine squared x. Sine squared x plus cosine squared x is 1. So this will be cosine of pi over 2 minus x minus 1 plus 1. So those two cancel out. That leaves me with cosine of pi over 2 minus x. Now there's one identity. We didn't focus a lot on this identity, but cosine of pi over 2 minus x is exactly the same as sine of x. And I'll take a couple minutes here just to explain how that really works, in case it's kind of hard to see. But let's say I have a right triangle, and we'll call this angle theta, or x, or whatever. And in this case, we'll call this one, we'll call this one y. Let's do y and x. We'll call that y, call that x, and then we'll just call that 1. Okay, so sine of theta is y over 1. So here, sine, so this is separate. Sine of theta is y over 1, or just y. Just y. But I can look at this other angle right here. This other angle is, so all these three angles need to add up to be 180 degrees, or in radians, pi radians. So this angle right here is pi over 2. So that's half of it. That's 90 degrees. This is just some number we don't know. This one's going to be 90 degrees minus theta, or it's going to be pi over 2 in radians minus theta. So that's this angle here. So when you have something like cosine of pi over 2 minus x, we're looking at the angle opposite of the one in standard position. And if I did cosine of this angle, well, that's adjacent, which is y. Cosine of pi over 2 minus x is just adjacent, y over 1. These are the same thing. We're just talking about opposite angles, or different angles of the same triangle. The opposite side of theta is the same as the adjacent side of pi over 2 minus theta. Okay, I will end this video here. One more page. Yay!